So next one is called candies. Let's take a look at it. Okay, so n children have got m pieces of candy. It's pretty apropos for like around Halloween season, I guess. They want to eat as much candy as they can, but each child must eat exactly the same amount of candy as any other child. This is very egalitarian. Determine how many pieces of candy will be eaten by all the children together. Individual pieces of candy cannot be split. Okay. So, M is, I guess, like the total number of candies that they have, like the total pieces shared throughout all of these children. And in this case, there are 3 of them. So it's kind of like we're saying, all right, we've got 10 of these things, and if we can distribute one to each of them, we will. If we can't, we won't. So I guess in this case, like, there'll just be one left over. Like, we've got the 10, we give one to each of them, another to each of them, another to each of them. They've each got 3, there are 3 of them, that's 9. We don't have enough left to feed each of these hungry mouths. So basically at that point, we're gonna say, okay, that's the best we can do. So how do we deal with this? Well, I guess we could say something like, okay, we'll use some loops first of all, and we'll say something like, let candies each. Okay, something like that. Just I'm trying to come up with a descriptive name, but we'll start this at 0. This is going to be how many candies each of these kids have or will get. So let candies each be assigned the value of 0. And I guess we'll just say while m is greater than or equal to n. Yeah. Well, m is greater than or equal to n. And what are we going to do with that? Well, I guess, okay, here's my reasoning, all right? If the number of candies that we have is greater than or equal to the number of kids that want them, then we can hand one out to each of them. We can afford to do that. If it's less than that number, then we can't afford to do that, so we should stop the loop. So basically, while we can still afford to hand out candies to each of them, we'll say candies each, plus plus. There's one more for that one. Okay, and then we want to return candies each at the end. Or at least let's return that for now. Let's see if we're getting it right. And something we'll notice about this first attempt is that it's timing out because we're not changing m. So what are we going to do? Well, we'll say the number of candies remaining is going to get subtracted by the number of children because we've just handed out a candy to each of them. So we're minusing n from this whole thing. Okay, so basically we only give them each a candy if we can afford to do that, you know, like if each of them can get one. Okay, so once we do that, we hand them out. And then we say, okay, now there's n fewer of them within the total number of candies. So let's run that. Okay, it's completing first of all. That's good. That means, you know, we're not timing out anymore, but we're not really getting the right values for a lot of these. So this one was fine. This worked okay. I mean, we had m was 2 and n was 1. There's one child. This one child is going to get both pieces. I guess that one's pretty straightforward. In this case, there are 10 children, but only 5 candies, so no one's going to get any. So we were right about those two. We were wrong about all the others. So in this case, the expected output is 4. There are 4 kids and there are 4 candies, and we want to know, you know, how many in total are they going to have, right? It's not saying how many will each of them have. It's how many pieces of candy will be eaten by all of them. So basically, it's however many each of them have multiplied by however many kids there are, right? So each kid has this many candies, there are this many kids. This should give us the total, and it does seem to be doing that. So let's just submit, make sure this is passing all the hiddens. Great. Okay, this feels good. This feels good. We're making some progress here. We're 38% complete the intro gates already, so this is nice. Whoops, I didn't mean to do that. Cool animation, but let's go back in here. Okay, so there's another way we could do this. You know, because if you think about it, we're basically kind of like doing division here, you know? Like, this is essentially what division is. We're just counting how many times does n go into m. That's it, right? I mean, like, that's division. That's fundamentally what it is. And we're going to have a remainder there sometimes, maybe not always, but we will sometimes have a remainder, as you do with division, right? So basically, for something like this, keep in mind what we're getting at the end here. This number is basically just m minus the remainder. Let me write this down. So m minus the remainder of m divided by n. Okay, m minus the remainder of m divided by n. Well, the remainder of m divided by n is just m mod n. That's what it means, right? So m mod n. That's basically what we want. Could we just use that? Like, would that work? And we'd have to delete this because we've modified m in this case, but is that what we're looking for? M minus m mod n? Yeah, it's what we're looking for. So we could submit that, and it works. No problem. That works. That's a pretty efficient way to do it. Oh, wait. I didn't change this one, so maybe it doesn't work. Let's find it works. Okay, cool. Sorry to worry you for a second there. Let's see if there's maybe one other way we can do it. And, well, yeah, spoiler alert, there's one other way we can do it. I'm actually not sure. I hadn't planned on doing this one. It just sort of popped in my head, but I'm not actually sure if this one's going to be better than that last one, so we'll find out, I guess. But we'll call this candies 2, first of all. And now, basically, the idea is that what we want to say is that we'll do a math.floor, right? We'll do math.floor of m divided by n. And we're basically saying that's the number of times n fit into m, okay? And we're taking the floor of that. So this number, 3, it fit into 10 3 times with a remainder of 1, but that's okay. We don't need to know about the remainder. We just want to know, take the floor, you know, how many times did you fully fit in there? Okay, and it fit in 3 times, but then we had to multiply that by n, you know, the number of children. So basically this thing, math.floor of m divided by n, that's candies each. That's what we're getting from all this stuff. It's just a lot easier to do it like this, math.floor of n divided by n. So then we just need to multiply this by n. And is that going to work? Yeah, it does. All right, great. Okay. Whew. Well, that's good. So, this has me wondering now, you know, which is better between these two? I mean, obviously there's a lot less characters, which, you know, would be good for some purposes. That can also sometimes mean that it's, you know, we're offering less description to the reader, so that could be bad in some ways. So I don't know, I guess it's whichever one makes more sense. I'm trying to think if there's like a performance difference. Like, I guess this one is doing a division, then it's doing a floor operation, and then it's doing a multiplication. This one's doing a mod operation, then it's doing a subtraction. So I guess it does kind of feel like this one's doing less work. I mean, it's fewer operations, but I wouldn't be able to tell you how, like, you know, the time complexity between like a floor and a division compares to that of a modulus, for example. That's a tough one. I'm not sure. But I also think that that's getting pretty, getting into like the finer details, you know, like that's getting really, really up close and personal. Like it's okay. All I'm trying to say is that's like for, you know, micro optimizations. Like, I don't think we need to worry too much about choosing this versus this in production. Then again, who knows? Like, you know, someone pop it into a JS perf and maybe prove me wrong. We'll find out. But for now, let's just verify that this is passing all the hidden tests. Okay, cool. So, yeah, we'll leave it there, I guess. We'll do, yeah, just these 3. I think that's good. Okay, cool. Let me know if you have any questions, comments, or concerns. And the official JavaScript The Game solution is number 33,138 if you want to click it. Okay.